So what we're going to do now is we're going to work on creating a master tube. We've already created our master sketch. We've gone over how to identify the tube centerline radius or the bend radius that you need a model to. And now we need to actually make the tube, a master tube. And what I mean by master tube is we're going to make essentially like a template that we can copy and paste over and over again and then modify each one individually as we put it in our assembly. So first I'm going to start with going to File New. I'm going to create a new part. So I'm going to model this master tube. Essentially, we can do any size we want along the way, but I'm going to start with let's say my structure is mostly 1 3/4 120 wall. So let's go ahead and make the master tube the majority of what our structure is going to be. So I'm going to start with a smart dimension, 1.75 for 1 3/4. I'm going to add another circle for the inner diameter, and then give it a wall thickness of 0.12. Okay, so there is our extrusion profile for our tube. And I'm going to start with just coming out about 4 inches. Alright, so we have a little segment of 1 3/4, and as you can see, if I go and I actually measure this, if I measure the outside, I've got 1.7500. If I measure the inside, I got 1.5100 because it is 0.120 wall. So this is correct. Now, the one thing I want to do that's really important, do not skip this step, is click this down arrow and show the sketch. I'm going to show you why this is extremely important later, as it'll save you a lot of time if you do this. So just make sure this sketch is shown. So you can hit the down arrow, hit the sketch, and then hit the eyeball. And then you're going to get that sketch showing in there. You'll see that there's a center point vertex, and then there's also the inner and outer profile that we use to extrude the tube. So the next thing we're going to do now is we're going to add a part number to this tube. So I'm going to pick a plane. I'm going to start with the top, and I'm going to hit sketch. And then I have my keyboard set up so I can go normal to. So I'm going to go ahead and hit normal to, which can also be found right here, normal to. So that'll be wherever I click on a plane. I can click here, and then hit normal to. And this is the beginning of the tube. You can see my sketch is kind of hidden in there because we're looking at it straight on. But what I'm going to do is I'm going to draw an underline for our sketch. So I'm going to make this, let's make this 1.5 long. We're going to make this line 0.02 thick. This looks really good on a laser when you cut it. And then from the end of the tube, I'm going to give it a dimension of 1.5 inches. That way our part number doesn't make it accidentally inside of our cope if we're coping this right here. And then I can start with 0.2. Seems to be a good go ahead. Now you can play with these numbers. You can, honestly, once you understand this concept, you can mark this however you want, but I'm just showing you exactly how I go about starting it, and then we can manipulate it along the way. So I'm going to go ahead and exit that sketch, and you can see that that's floating inside that tube. I'm going to hit Features, Extrude Cut, and I'm going to offset it. So what this is going to do is it's going to raise it above the surface of the tube. So I can just put like 2 inches in there. And then I want to cut down offset from surface. So I'm going to click the surface of the tube. And I want to go, let's say, 0.01 deep into the surface. So if I zoom in, I'm actually floating 0.01 above the surface. And I want to actually cut into it. So I'm going to hit reverse offset. And now I'm cutting into the surface. So when I click this, I now have a partial depth that's cut into the tube. So what does this partial depth do? Well, what's cool is that we have our software set up so that when we import from SolidWorks, if you have anything cut in the outside surface that does not come through the inside surface, it will come up as an automatic mark. So this could be lines that help you identify the position. It could be your part numbers. It could be anything. So it does not matter what the depth is. You can cut it 0.001 inches deep. As long as it breaks the outside surface but doesn't break the inside surface, our software will automatically pick it up as an edge. So right now, if I were to import this into our nesting software for the tubing, this would come up as an etch line. It will not cut it. Now we're going to move on to being able to automatically part number these. So I'm going to go back on the same plane, which is the top. I'm going to create another sketch, and I'm going to click the text. I like to click this bottom line, And this is where it gets really cool. Right here, you'll see link to property. So instead of typing anything in, I'm going to go link to property. Okay, so this screen's going to pop up. And under property name, the very first one is SW, so SolidWorks file name. I press OK. And you'll see it's automatically populating part 1, which is the file name that was created by default for this thing. Now, I want it to be it's on the wrong side of the line. I intended for it to be on this side, so it's in the middle of the tube. So I'm going to flip this over. Now it's backwards, so let's correct that. And then I want to adjust the size. So a good size for the laser, and this is just my recommendation. You could do whatever size you want, but I like 35. So when I go back into this font, points 35. It's a pretty good size because you can read it actually really well. I want to say a lot of people get pretty wild with the different fonts. Believe it or not, some of the fonts have such crazy splines built into them that there's some fonts that just don't work great. Honestly, the Century Gothic, I've never had any issues with them being crazy splines. So just try not to, click some crazy text like this. Like, it just won't work. When we import it, we'll get all sorts of errors. If you can stick to Century Gothic, it's just for part labeling. It's a great one. It will not create issues when we go to import it and have to, delay your parts being made. So go ahead and press OK and press the check mark. And now I have a new sketch just like I had my line, and I'm going to extrude cut it. I'm going to lift it above the surface, so 2 inches. Okay, and just so you can see the line, it's up here, right? And then what I could do is I could hit offset from surface and click the surface again. You're going to see it's hovering. Then I hit reverse offset. It's inside of it now. And now you can see I've got my line and I have my words. So why did I add this underline? Well, what's cool about it is if I didn't add that underline, the laser would have to lift up for every single letter. And this is not a raster laser. This is a laser that's actually following vector lines. So we are following these perimeters. And so every time we get to a point where we got to get to another detail, we'd have to pick up. So when we put this line on the bottom, we speed up our program and make it more efficient. So it is very important to make sure that you have this underline. It's not the end of the world to have some of these islands. We get lots of scenarios where there's 2 or 3, lift ups for a part, and it's pretty quick. What we're trying to avoid is, the head lifting up 100 times in order to part mark. So now we have this master tube driven off of what this is. So I'm going to go ahead and save this. I have my folder here. I'm going to call this master tube. Okay? And you see up here the name is there. If I hit the rebuild button or refresh, now master tube is populated. The reason why you don't see the beginning of the master is because our bottom line isn't long enough. So when you run into scenarios like this, you can always go in and make it bigger and more of the letters will appear. But honestly, none of our part numbers are going to be that long. It's just because we're looking at the master tube in particular. So let me move this back to 1.5 inches. All right, so we have a 4-inch extruded piece. Doesn't necessarily have to be 4 inches, but it's just a good rule of thumb to start with. We have a tube that's our outer diameter, our inner diameter, and then we made sure to show our sketch, and we also added part numbers that are driven off the part name. So let's go ahead and move on to bringing this into our sketch assembly.